Greetings and welcome, friends. Mr. Waddy here, and I'm showing you some new skills when it comes to factoring. What do you do? Have you ever had this problem when you were factoring a polynomial, specifically a quadratic, and then the leading coefficient wasn't 1? Blarg is what you would have done, right? Like, that's craziness. And it turns out we have a way to deal with that. The first technique I'm going to show you today is that what if, in this wonderful world, you could factor out that leading coefficient? And watch, in this case, I can. So for example 1, I can a-hey yoink, triple yoink. What? I can steal from all three of these terms. What is the greatest common factor between 5, 15, and 10? 2 doesn't go into 5 or 15. 5. And between x squared and x, I could have stolen an x, but 10 has no x's to give, and I can only steal what the poorest term can afford. So I'm going to steal a 5 from this, and because I factored it out of a trinomial, a 3-termed expression, inside parentheses, I'm expecting 3 terms, okay? So 5 times what would have been 5x squared? What do you guys think? 5 times what is 5x squared? Well, I would need the x, and I need the x squared, right? And the 5 times the 1 would give me the 5, and I'd be all set. Let's see. 5 times what would have given me 15x? Or 5 times what is 15? Let's start there. 3, right? And that's a positive 3, yep. And that needs the x there as well. And then lastly, 5 times what would have given me 10? 2. Yep. And if you don't like those questions in that way, you can also ask them in reverse and say, right, 10 divided by 5 is what? And you'd get 2. And so I factored out the GCF, but what's interesting here... Goodness, wow. I've sneezed on the internet before, but it's okay. The inside of this can actually be factored even more. What? Craziness. I'm going to find the factors of 2, which are 1 and 2, and figure out which of those add to be 3, right? Because inside here is a positive 1 leading coefficient for that x squared now, all right? And so let's see. So when I factor this, the 5 is still hanging out, and this inside parentheses is going to factor into 2 binomials being multiplied, just like we've done before. So I'll have an x with a 1 and an x with a 2. And to figure out their signs, well, they've got to multiply to be positive, so that means they're either plus plus or minus minus. The signs are the same. And they add to be positive, so which combination works, my friends? Plus plus. And now this is factored fully. All right. Well, let me ask this. No, don't worry. Let's look at this. Just the inside, you guys know how to do, right? Right. If this is what I gave you, you guys know how to do that. Just this part, technically, maybe we don't remember, but we know how to do factoring out the GCF. I just steal the biggest thing that each term could afford and write what's in parentheses. So this problem combined both of those skills, and once I got that GCF out front, I then factored just the inside. But that 5 is still hanging out, okay? And if I was to multiply all this out, it would bring me back to the beginning. So we'll be able to practice some of those tonight, so don't you fret. Don't you fret. For the quest. All right. Trickier is when, sometimes I can't factor out the leading coefficient. I might not be able to factor out a number from the front, and then I've got this multi-stepped, more difficult process, but the benefit of this process I'm showing you is that it avoids a lot of guessing and checking. And I showed my students here in real life, even the books method for doing these problems. And there was one of these problems that had like 20-something possible ways in which they had to factor these, which was just like craziness. Now, instead of reading this out to you right now, I'm going to look at the problem, do step 1, and then go back, and look at step 2, and do step 2, and then go back. All right, so step 1 says multiply A and C. Now, A and C, they're talking about the coefficient of my squared term and my constant term. So let's look at example 2. All right, part A, and it says multiply A and C. All right, so AC, I'm going to multiply that over here, is equal to 4 times 3. What is 4 times 3? 12. Okay, yeah, 12. So multiply AC, step 1 is done. Step 2, find the factors of AC that add to B. Okay, because AC is positive, right? Those multiplied to be a positive 12. So I'm going to find the ones that, because this is positive, find the ones that add to 13. And so here we go. You probably can already guess them, but I'll write them all out. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4, right? This part feels familiar. You've done this part before. So find the factors of AC that add to 13. So the ones that add to 13, hey, 1 and 12 add to 13. These added to 10, these added to 7. So 1 and 12. Now, step 3, what I do with those is going to be a little bit tricky. All right, but follow me here. Follow me. All right, step 3. I'll go back, don't you worry. Oh, with the save, Austin, thank you, sir. Yeah. 6 and 2 add to 8. Ah, with the save. Thank you. Always, please correct me when I'm wrong. Well, let's see. I'm going to keep bouncing back and forth. Step 3. Okay. Split the B term. So the B term is the term that has the X in it into 2 like terms. Like terms are those that will have X's in them in this case, whose coefficients, does someone remember what coefficients are? The number in front of a variable. Yes, okay. Whose coefficients are the factors we just found. Which factors we just found? The factors of AC that add to B. So let's put this into practice because all these steps sound weird. All right. So I'm going to split this B term. I'll use a different color here. So 13x is now going to be broken up into 2 cases. All right. So watch what I write. 4x squared is still here. All right. Now I'm going to have I'm splitting the B term into 2 like terms, so they're both going to have x's on them, and their coefficients are going to be the 1 and the 12. So I'll have a 1x, which you don't have to write that 1, and a 12x. All right, and then the plus 3 is still there. And now as far as their signs, this x, this 1x, and this 12x, the 1 and the 12, have to multiply to be positive. So they're either plus, plus, or minus, minus. And they have to add to be 13, a positive 13. So in this case, they're plus and plus. All right, that is the trickiest step. All right, let's just recap. Multiply AC, find the factors of AC that added to 13, my B term, and then split the B term into those factors for their coefficients. All right, we'll practice plenty of these. Don't worry, we've got a couple days we're spending on this. Let's go to step 4. This whole step is called factor by grouping, and it's a factoring technique that is used when you have 4 terms. All right, which is what I have right now, right? Because I split my B term. I've got 1, 2, 3, 4 terms. Now, technically, I know I could combine those. Those would combine to be the 13x, but I don't want to do that. It says factor out the GCF from the first 2 terms and factor out the GCF from the last 2 terms. So watch what this looks like. Here we go. All right. So between, just for these first 2 terms, between 4 and 1, I could only steal a 1. But between x squared and x, I can steal an x. All right? So I'm going to write x outside a set of parentheses, and I'm just doing this for the first 2 terms. Okay, so x times what is 4x squared? Well, that would be 4x. And x times what is 1x? That would be 1. All right. And now I'm doing the same thing for the last two terms. So between 12x and 3, what goes into both 12 and 3? The biggest number that goes into both of them. Yeah. 3. And this one has an x, but this term doesn't, so I can't steal an x with it. All right? And this is a positive 3. I need to have a plus sign here. So I'm going to write plus 3, and then outside parentheses, I've got to figure out what would have given me this. So 3 times what is 12x? 3 times what is 12? No. 3 times 4 is 12, and then I need the x. And 3 times what is 3? Yep, and that's a positive 1. Now notice, if you've gotten this far, your two sets of parentheses, what do you notice about those two sets of parentheses? They're the same. They actually must be the same. Absolutely must, okay? If they don't match, that means you did something wrong prior. So you can use that as kind of like a quick check. All right, so I just did that. I factored out the GCF the first two, the GCF the last two. What's this last part here? Write the duplicate factors, right? Those two sets of parentheses matched. Write them in one set of parentheses, and the two GCFs in another set of parentheses. So the factored version is going to be in one set of parentheses. I'm going to write the duplicates, 4x plus 1, and I only need one of those. And in the last set of parentheses, I'm going to write the x and the 3, the plus 3, or this x and this plus 3. And this is the factored version of this problem. Now, I took a bit of time on that because it's the first time we've seen these steps. But if you were to do it the guess and check way, there's like 4 different factors there. There's 2 different factors here. I would have tried 8 different combinations. And then I'd possibly also have to double that to consider the signs. So possibly 16 combinations to factor this. Like, it's craziness. All right? And this will lead you to the outcome, or it will tell you that it's not factorable far quicker than guessing and checking. All right? So let me do the same thing for part B here. So let's just follow along for part B. All right, step 1, multiply A and C. Okay, so AC. Nope, just the A is 3. And positive 3 times positive 2 is what? Positive 6. All right, and now I'm going to find the factors of 6 that add to be 7, ignoring that minus sign for now. Let's see, 1, 6, 2, and 3. And you guys can probably already tell, right? 1 and 6 add to be 7, 2 and 3 add to be 5, like so. I'll let you guys catch up. And one plus 6 is 7. 2 plus 3 is 5. Right, so the pair I picked was the 1 and the 6. And now, step 3 was tricky. Split the B term into 2 like terms whose coefficients are the factors we just found. So I'm going to rewrite this entire problem as 3x squared, and then I'll have a 1x, all right? I won't write the sign yet. So an x and a 6x, and then the plus 2 hanging out. And now I've got to figure out what sign goes here and here. Now they multiply to be positive. So that means they're either plus plus or minus minus. But they add to be negative. So which combination do you think would add to be negative 7? It's either plus plus or minus minus. That was not an option. No, that's also not an option. Minus minus. Oh dear, I just like zoomed in accidentally here. I'll scroll down again. No, that's not part of my job description. So let's see, minus minus is what I get, okay? Let's see, now step 4 is the factor by grouping. So for these first two terms, I'm going to steal an x, and for these last two terms, including this minus sign, I'm going to steal a -2. It's weird how it keeps like scrolling around on me. Bizarre. Pretty sure I shut off the touch input. What is going on? I'm going to shut off this mouse in case that's the problem. All right, let's finish this problem. Because ghosts are in here. All right, so I could steal a -2 from both of those. So I'll have x, oh, wrong color. Let's see, x times what is 3x squared? That would be 3x. X times what is -x? That's -1. And here I'm stealing a -2 out. So I take that sign with it no matter what. And -2 times 3 is -6, and I need the x. And -2 times what would be +2? Times what would be +2? -1. All right, and now, hey, my two sets of parentheses match. And so in my answer, the last part is write your duplicates in one set, so 3x minus 1, and write your GCFs in the other, x minus 2. All right, lots of steps here, I realize. We're gonna get plenty of practice at this. It'll be a-okay. Thanks for watching, internet friends. Have a great day. I forgot I shut off that mouse. Bye-bye.